Good afternoon, everybody. Welcome back to the final session for the day and the final session for LCA in this room. We have Yemel joining us from sunny London town, where it's a beautiful 5 degrees outside and 6:45 a.m. So all of us who are having coffee to get through the rest of the day, Yemel's probably starting his to get him going. So Yemel's a long-term Debian developer working from London but working out of Norway. So I feel his sympathies with him working for an international company. The clock is always wrong no matter where you are in the world, somewhere that you're working with and having a meeting with. So Yemel, over to you and looking forward to hear all about Debian Janitor.
All right. Yeah. Thanks, Michael. Yeah. So today I'm gonna talk about various ways of automating Debian packaging, and this is a continuation of work that I've been doing for the last couple of years. And what I'm going to talk about today is something that's part of the Debian project, but a lot of the lessons and the tools apply outside of Debian as well to other distributions, but also to upstream projects. So let me start by giving a little bit of an introduction to Debian. You're probably familiar with it, but maybe it's good to sort of take a closer look at actually what a distribution is trying to achieve. So Linux distributions like Debian fulfill an important function in the foss ecosystem. There are system integrators that take existing free and open source software projects and adapt them where necessary to work well together. They also make it possible for users to install more software in an easy and consistent way, and with some degree of quality control and review. And of course, you could argue over how much review and quality control happens for some packages in Debian, but at least there's some minimal bar. So packages have been reviewed for their license. They have to meet certain parts of the of Debian's rules, Debian's policy, and there are mechanisms to encourage conformance where the policy is not absolute. And in the same way, Debian makes some promises around how long security updates are provided, for example. Now, if you were installing software directly from an upstream project, you would only be able to get these sorts of guarantees for a certain number of upstream projects, but you wouldn't be able to get that consistency across all of the things you install. And there is some variety between Linux distributions, so Debian falls squarely on the side of trying to integrate the different upstream projects more tightly, and generally has much more complicated patches and packaging, and other distributions fall more on the other side, and they have much smaller shim around the upstream project, like Arch, for example, where the packaging is much smaller. It's much easier to make packages, but there's also less integration work that has happened. Now, you've probably heard of Debian, even if you haven't used it. Debian is one of the older and larger distributions. Debian has about 1,000 uploading developers and many more people who contribute changes on a regular basis. There are about 30,000 source packages in Debian, and that basically means that there are about 30,000 upstream projects that get integrated into the distribution. So that's quite a lot. And there are many more binary packages that get created from those 30,000 source packages. And then Debian has a large policy that specifies what packages, binary packages in particular, should look like and comply with. The development of the policy is mostly consensus driven, but the policy also tries to be generally flexible about how it is met. So maybe the shape of a binary package is particularly well documented. You can use many different tools on the build side to achieve that. So there's no, it's not very well dictated exactly how you should do that implementation. And then, of course, there are many tools available that can do the same thing. And then each package has a single owner, so-called maintainer, and with team ownership now being more common than individual maintainership. So generally, there's a set of people who maintain usually a large number of packages and keep those packages in a good shape. That's different from some other distributions where the ownership model for each package is often a lot weaker and where it's more common for other contributors to step in. It's not hard and fast in Debian either, but traditionally it's been very much that there was a maintainer who took care of a package and nobody else would really touch it. And then source packages in Debian are essentially just tarbals with some Debian-specific metadata. And uploading a new version of a package generally involves copying some PGP-signed tarbals around. So that's how Debian started and how the basics work. But things have moved on since the distribution was originally created. When Debian started, source tarbals were the way of delivering software, either on a CD or a floppy, or maybe even over this shiny internet thing. And that was true for both upstream projects as well as Debian itself. Nowadays, Git is fairly ubiquitous, and most upstream projects and most packages in Debian use it. And there are still exceptions, of course, that don't use any version control system at all, or maybe that use a different version control system. But those exceptions are getting more and more rare. As a version control geek, I'm a little bit sad that we have this monoculture now. But Git is a really great tool, and it's nice to not have to deal with half a dozen different systems like we had to back in 2009. So today in Debian, there isn't really a predictable location for where Git repositories with Debian packages live. However, we've worked around that by adding a header to the Debian control file in the source package that points at the Git repository, or technically could also be the Mercurial repository location, the Bazaar branch location, the Subversion repository location, the Arch location, CVS location, or the monotone repo location. But as you can see from the graph on the right, basically all of the packages nowadays use Git, and there are some holdouts that don't use any version control system at all. These headers have been around for quite some time, but they're awesome, and there are tools around them to automatically, for example, check out the Git repository for a package. And there's a service that will monitor all of the packages that have these headers set, and that will notify you whenever, for example, a repository goes away, or when it breaks, or when it doesn't match what's in the archive. And for most packages, this header is pretty accurate, which is great. Right, and then there's another control file in Debian packages called Debian upstream metadata, and that's a standard that defines a format based on YAML that allows the maintainer to specify various bits of metadata about the package's upstream project. So, for example, where does the Upstreams documentation live? Where's its wiki? Where can you report bugs? But also, where does the upstream project's version control system live? There's a little bit of overlap here with other control fields in Debian, but that's something that's being worked on. So this format is a draft, but it's been widely adopted. There's about 10,000 packages or so that have this file present, and about 8,000 of those have the repository header set. So for about a third of all of the 30,000 source packages in Debian, we know where we can find the upstream source repository. And if you're a maintainer, you can use the guess upstream metadata command to automatically generate one of these files, and that command will actually do things like introspect setup.py if you're a Python package, or look at the make file, or in some cases, it'll even just scrape the README file for anything that looks like a Git repository, and it tries to see whether it matches what's in the package. Another innovation that's happened in the last couple of years is autopkgtest. So autopkgtest defines a framework for running tests on a Debian binary package. So when you run them, you can be sure that the package has been built correctly and functions as a user would expect. So about half of the archive now has these set, and that is great because it allows you to verify when you make a change that you haven't broken anything significant. There's also a service, ci.debian.net, that regularly runs these tests against packages, as well as their dependencies, whenever one of them changes. And then finally, one of the recent developments, or rather one of the things that has been evolving is a gradual adoption of just a single tool for building packages. So in the past, there were many different ways of building a Debian package. You could pick a random package from the archive, and depending on the maintainer's preference, you would find one of about 5 different tools. And you would have to be familiar with all 5 different tools if you wanted to contribute to a random package. One of the, or the tool that we've sort of settled on is called debhelper, and the debhelper DH interface in particular. And one of the other things that's nice about the DH interface is that debhelper can increasingly figure out how to just do the right thing rather than requiring a lot of configuration. So that makes the packaging less effort, but it also means that it's less likely that, for example, when you import a new upstream version, that you will need to make extensive changes to the packaging. So that's sort of a lot of background on what has happened in the Debian ecosystem over the last maybe 5 to 10 years. That has made has improved the way we can make automated changes. So let's now have a look at making large-scale changes in the Debian ecosystem, because there are some unique challenges, because every package is basically maintained as a project by itself. So if you've ever touched a Debian package, you're probably familiar with Lintian. So Lintian is a linting tool that can scan Debian packages and report common packaging issues. So it categorizes issues by so-called tags, and you see the documentation for one of those tags here. So this tag in particular, carriage return line feed, gets reported whenever a Debian control file contains carriage return characters. Carriage return line feed characters, and suggests that maintainers basically strip the line feeds from there. Many build tools in Debian will actually run Lintian straight after building. And the hope is that, like, if we report these tags, that maintainers will go and fix them. And so the traditional way of making changes across Debian packages is to somehow make developers aware of an issue, for example, through a Lintian tag or bug reports, or maybe some other form of communication. And then you get everybody to pick up on the problem and fix it. So you get them to care and make the appropriate changes and upload new packages to the archive. And then after you've done that and you've waited enough years, you may end up with a significant chunk of the archive fixed. Generally, though, there'll be a long tail of packages that aren't updated. There are a bunch of packages in Debian that haven't been touched in years, like maybe they've been rebuilt. But if they've just kept building, then there's generally no need to change them. But as you can see, this is a very slow process. It also requires a lot of cumulative time across all Debian developers. So not only do they all need to be aware of the details of the problem, they also all need to allocate time to actually make the changes and to upload a new package. And frankly, for a lot of problems, that's probably not worth the effort. So let's go back to that Lintian output. You'll notice that Lintian actually tells you the command to run to fix the issue. So what if rather than requiring the user to run Lintian and then copy and paste the command, we just ran the command for them? So that's basically the idea behind a tool called Lintian-Brush. So Lintian-Brush is a set of more than 100 different scripts that can automatically fix common Lintian issues. There's also a framework that allows you to write those scripts easily and to run them. So the framework provides all of the interaction with the Git repository for you, so you don't have to worry about that. It'll also take care of updating the Debian changelog file for you if the package doesn't use fancy tools for generating the changelog. And it's got all kinds of cleverness underneath. So when you run the script, it uses inotify to figure out when you make changes to the package. It manages the git adds and removes. It creates the commits if there are multiple scripts that run. It cleans up if a script fails to run. And then, as mentioned, it will update the changelog file appropriately. Most of the fixers do things that would take developers a couple of minutes each. And this basically just makes it at most a couple of seconds. Per package, this kind of automation doesn't really make that much of a difference. Like you take it down from maybe a couple of minutes to a couple of seconds. But you can just fire and forget. And you can also, if you look at the entire archive, the impact is more significant. And if there's nothing for the tool to do, it'll usually run in less than a second. And this is an example for what one of those scripts looks like. So this is written in Python. Most of the heavy lifting is done by the framework, but in this case, it's fixing a particular field in the control file where previously Debian supported a priority extra, and that's been removed and should now be replaced with priority optional. And the way that the framework is written makes sure that if there are formatting specialties, they are preserved. And if the script can preserve the previous formatting, it'll just raise an exception. That exception isn't handled here. The script will fail, and its changes will be discarded. However, that having one of those tools and available doesn't mean that everybody automatically starts running it. So this is a graph of the total number of installations of Lintian-Brush from Debian's popularity contest program. Lintian-Brush has been around since mid-2018. Ideally, we'd like to see it run over all 30,000 packages in Debian on a regular basis. But that's not something that can easily happen. And so one of the things that we would really like to do is to run it across the archive without having to get every single developer to every month run it on each one of their packages. The way to do that is to basically bring the changes to them rather than requiring them to run the tool. So we make it easy for people to apply these changes by creating merge proposals with the changes. And there's a tool called Silverplatter that automates all of that. So it iterates over a set of Git repositories. It applies a recipe, which is generally just a command to run in the Git repository. And then if there were changes created by the recipe, it proposes them in a pull request. And so this means that a single person can come up with a recipe, can run it against all of the archive, and the only thing that maintainers have to do is look at the merge request and hit the merge button if they think the changes are reasonable. And the tool can also directly push to a Git repository. So if the user running it has appropriate permissions, it can just directly push to the repository. And then this is what it concretely looks like. So there's a YAML file with the URLs for the repositories to process. And those can also be just names of Debian packages, in which case the tool introspects the headers that I mentioned earlier. And then there's a recipe which basically specifies what command to run and a template for the pull request that needs to be created. And then you can invoke the commands on those two files, ideally starting off with a dry run to see if the changes are reasonable, and then you can run it, and it just iterates over all of the repositories. It can also build the Debian package to verify that you haven't accidentally broken anything. So that's all well and good, but Debian has about 30,000 source packages, and using a command line tool to dry run, review, and upload 30,000 changes is going to be quite challenging. There's another project called the Debian Janitor, which sits atop Silverplatter and provides a web interface. So it looks at all of the packages in Debian and regularly processes them to make sure that Lintian-Brush, for example, but other tools as well, get run regularly. So the Debian Janitor is basically, it's a website as well as a scheduling interface that constantly watches the Debian archive, processes the entire archive regularly, as well as packages that have been changed recently. And then in addition to that, it provides an interface where you can actually look at these changes, and you can do QA and review, as well as managing all of the merge requests that are open. And one of the more challenging parts of it is how to do this in such a way that it delights users rather than annoying them. So there are some risks here. The goal behind all of these tools is to save developers time and effort by automating away things that can be done by a robot, so that the developers can focus on things that require human judgment. But there's no time saved, and in fact, quite the opposite, if the pull request is incorrect. So the developer ends up spending time looking at the merge request, and the package in the end isn't improved. Oh, and then when the developer gets another merge request, they're probably going to be less likely to review it. And they're also going to be less likely to just give the bot blanket access to the repository. So therefore, the actions of the bot are restricted to a very limited set of problems for which there is an obviously correct action that can be taken. And it's not meant to automate all packaging or even to cover automating all instances of the issues that it knows about. So basically, if it's unsure about something, it just does nothing. There's nothing really lost there. Some packages use very complicated packaging methods that Lintian-Brush just doesn't understand. For example, there are control files that are generated in complicated ways. I'm looking at you, people who use M4 to generate your control files. And Lintian-Brush just ignores those. And then when we process the archive with the Debian Janitor, we only allow changes that we have a very high certainty about. After changes have been made, we do a build of the package with and without the changes, no matter how trivial those changes were. If that fails for whatever reason, we discard the changes. Then we run the autopkgtest as well. If one of those fails, we discard the changes. And then finally, there's a QA step where a human looks at the source package diff. And sometimes that also helps us catch issues. And then finally, we only open a single merge request per tool per package. So if we process the package again, we'll just update the existing merge request rather than creating a new one and having you look at that again. And then per maintainer, there is a rate limit on the number of open merge requests. So we don't really want to spam you with 100 merge requests if you have 100 packages that you maintain. So what we do is basically TCP slow start. So we'll send you one merge request. If you ignore that, we won't send you any more. If you merge it, we'll send you 2 more. If you merge those, we'll send you 4, etc. until we reach a limit of 20. And then in addition to that, the bot tries very hard to identify itself as a bot so that you know that the merge request is automated and can prioritize its merge requests appropriately. But otherwise, you can just interact with it as you would with a merge request that came from a human. So basically, if you comment on one of the merge requests, one of the developers from the janitor will look at your comments. So then how much does it take to keep this beast running? One of the key things that we look at regularly is the rejections of merge proposals. So if people close merge proposals without merging them, they'll usually leave a comment, and we go and we look at why they closed those. So in some cases, they've already made the change themselves, or maybe they introduced a merge conflict before they noticed the pull request for the package. In other cases, sometimes they disagree with the change. So sometimes we end up discussing the change with them, and occasionally that leads to bug reports for one of the tools involved in the change. If we find a bug that might affect other pull requests as well, we go and proactively find all of those pull requests and we reprocess them. And then if we can't fix things immediately, we'll just disable the tools in question until we fix the issue, so that there are no developers that end up looking at changes that we know are wrong. Of course, reviewing all of these changes takes quite a bit of time as well. Every single change is still reviewed by one of the Janitor developers before it goes out in a pull request. But that's something that I'm hoping to automate away in the near-term future. So at the moment, this is like hundreds of diffs a day. And that's quite a lot of manual effort. So that's what's been happening for about a year and a half. What have we achieved so far? So, unfortunately, we're in the process of gluing the history from our old and new database together. So I've only really got good graphs from up until last September. But this is the graph with the number of changes we've directly pushed to packaging repositories up until that point. So this is for repositories where the maintainer has given write access to the bot. And as you can see, we've almost hit the 10,000 changes mark back in September. And in fact, we've since gone over that. And then there's the number of merge proposals or pull requests, depending on the terminology you want to use. So we've had about 7,000 of our merge proposals merged so far, and we've got about 1,000 more open at the moment. We have many more changes queued up to propose, but because of the restrictions that I talked about earlier, we haven't created those pull requests yet. So that's all because we will rate limit the number of pull requests that's open for an individual maintainer. There's some interesting artifacts on this graph. That's mostly related to either to the tooling being paused when we discovered bugs, or related to the freeze for the Debian release early last year, when we stopped submitting pull requests. And then this is how the merge proposals are distributed over the different hosting sites. So it's an earlier snapshot, so the numbers don't quite add up to those in the previous graph. But as you can tell, all of the changes happened, or most of the changes happened almost exclusively on Salsa, on Debian's own instance of GitLab. And the rejection rate is fairly low. So closed basically means that the maintainer closed the merge request and didn't accept it in any way. There are a couple of challenges still associated with this. So if you get your changes accepted and merged into a Git repository, that doesn't mean that they end up in the archive. It might take years before the changes that were merged into a Git repository are actually part of an upload to the Debian archive. Last week we checked, about 52% of changes haven't actually been uploaded yet. There is some work ongoing to make it easier for people to upload changes that are in a Git repository to the archive, but those haven't landed yet. And then there's also some challenges around the long tail of packages that haven't switched over to a version control system yet, or that still claim that they are hosted on Alief, which is the previous hosting platform that Debian used, and that was deprecated, I think, over 4 years ago. So maybe we should consider alternatives like maybe not creating pull requests, but maybe sending bug reports with diffs attached. And then finally, one of the challenges that we have with GitLab is the fact that for a lot of repositories, there's nobody who gets notified when there are pull requests. So the pull requests just sit there, and that's not because people don't care, it's just because they don't know about the pull requests. So I talked about Lintian-Brush earlier, that fixes smaller issues in Debian packages, but there are some other very common operations that packagers do that could benefit from automation. And with the recent improvements to the ecosystem that I was talking about earlier, it actually becomes feasible in a lot of situations to update a Debian package to a new upstream version automatically. Of course, that requires that the packaging Git repository is available and that the upstream Git repository is available. But for a lot of packages, we actually have that information. If we can make this work for some fraction of packages, even if it's like 10%, that could still be very variable because it's about 3,000 packages. Yeah, and one of the consequences of Debian's model is that the distribution packages often lag behind upstream releases. So that's especially true for distributions where it takes more work to integrate a new release. And there are users who would prefer more of a rolling distribution. So yeah, what does the process look like for updating a package to a new version today? There's a lot of individual steps that a maintainer needs to take, and some of these steps are now somewhat automated, but until recently there wasn't really a single command that could replace all of these. As part of the janitor work, we've developed a new command that you can basically just run in any Debian Git repository, and that will attempt to pull in a new upstream release or a new upstream Git snapshot. And it takes care of all of the work that needs to happen along with that, such as updating the changelog, to some extent updating the packaging as well, building and running the test for the package, etc. This is all of the steps that it goes through. I won't go into detail, but I'm happy to talk about this afterwards. So this importing of new upstream releases has been happening for the last year and a bit. And we've attempted to import a new upstream Git snapshot and a new upstream release for every single package in the archive where the required information was available. And this is what we ended up doing. So for about 20% of packages, we managed to successfully import a new release. And that's about 2,200 packages, which I'm pretty happy with. There's also a whole bunch of packages that were already up to date, many more than I actually expected. So about 35% was already at the latest release. And then if you look at the failures for the other packages, there are a variety of reasons. So some of them are just random build failures, which is to be expected. Some are related to us not being able to find the new upstream release because we don't know where it's hosted. Some are due to just errors importing tarballs, and in a lot of cases, the Debian specific patches no longer apply when we update the upstream release. And then similarly, if we look at importing Git snapshots, you can see that we are successful about 20% of the time as well, but this accounts for about 5,500 packages. And in a lot of cases, we don't actually know where the upstream repository lives. And then some of the other errors are very similar to those when we were importing releases. So merge conflicts or patches that no longer apply, or tarballs that don't import. And the packages that get built as part of this process are actually available. So if you'd like a Debian release with very experimental packages with newly imported upstreams, you can go to that URL and find the instructions on how to add those apt repositories. And then, yeah, what's next? So there are a bunch of improvements that we still need to make in order to get more of the upstream imports to succeed. And then in the future, we'd also like to look at automating backports. So in particular, automating the cherry picking of security fixes to stable packages, as well as automating backporting of unstable packages to stable. And there's a whole bunch of work that needs to happen for Debian patches to be updated appropriately. And there's some harder problems that we haven't really looked at, such as transitions, so packages that need to be updated in lockstep, for example. And one of the things that I would like to look at is how we can apply some of these tools outside of Debian. So there are some existing projects that do things like modify repositories to, for example, reformat things, but that generally happens on a as part of existing changes rather than proactively. GitHub has a bot called Dependabot that proactively submits changes to repositories, but it's proprietary and it's specific to GitHub. And there's some unique challenges if we start doing this outside of Debian, such as which projects will we do it for? What are the standards that we should try and aim for? And how actually do we build a random upstream project that we find somewhere on GitHub? All right, that's all I wanted to talk about today. Thank you very much for listening. And also thanks to all of the people in Debian who've sort of worked on the infrastructure that made this sort of work possible. So with just bare tarballs, none of this would have been possible. From metadata and standardization for the repository fields to the ultimate Debian database, Lintian, the CI systems, as well as Jenkins, which runs all of the workers for the Janitor. And this is where you can find more information about the projects. Thank you very much.
Fell for it again, my apologies. So Jelmer, thank you so much for your talk and teaching us more about Debian, which I didn't know a lot about, and let alone the Janitor heard of merging. I'm really new to this world, so thank you so much. We've really only got a few seconds left in this room. The conference is not over, but the stream is over in this room. So if everybody please now move back to the main room, which is the KO room, and we'll have the conference close out. So we'll be wrapping up here in a few seconds, and we'll over to the KO room back in the main portal. Thanks everybody for joining LCA. Have a fantastic rest of your Sunday. Coming up in London, and for those of us who are ending our Sunday, may your week go well. Thanks for your time and putting up with my oopses of being on mute when I shouldn't have been. Bye, everyone.